process monitor on Windows. In contrast to Unix-like systems, Windows implements its user mode network functions without direct system calls. So the networking stack is exposed through the driver, and establishing a connection uses the file open, read, and write system calls to configure a network socket for use. Even if Windows supported a facility similar to strace, this implementation makes it more difficult to monitor network traffic at the same level as the other platforms. Windows, starting with Vista and later, has supported an event generation framework that allows applications to monitor network activity. Writing your own implementation of this will be quite complex, but fortunately, someone has already written a tool to do it for you. This is the Microsoft's Process Monitor tool. So let's download this tool here. Just search in Google as here. Oops. Search in Google as Microsoft Process Monitor tool. Actually, yes, Microsoft Process Monitor tool. Here. These internals process monitor. And click on the Microsoft official website here, and in the download sections click on download. Okay, and extract from zip file. Okay. So as you can see here, to main interface here, so selecting the filter here, as you can see here, filter, process tree, include process tree, highlight filter here. Oops. So let's close this. So selecting the filter displays only events related to network connections from a monitored process. Details include the host involved as well as the protocol and port being used. Although the capture doesn't provide any data associated with the connections, it does offer a valuable insight into network communications the application is establishing. Process Monitor can also capture the state of the current calling stack, which helps you to determine where in an application network connections are being made. Actually, this will become important in next lectures of our course when we start reverse engineering binaries to work out the network protocol. Here we have columns here, as you can see here: time, process name, process ID, operation path, result, and detail. So actually, let's increase this size a little bit. Screen. Turn off screen here. Change screen resolution. Let's make it a little bit scalable here. Oops, it's even worse now. So as you can see here, we have columns here, which this column time here shows the name of the first we have to process name. Let's start with process name. This process name shows the name of the process that established the connection, and this column here operation here shows the operation, which in the case is connected to a remote server. Here, as you can see here, registry open key, query key, here read file, log file, like that. And we have path here as well, as you can see here. This path actually indicates the source and destination addresses, and this is a detail here, as you can see here. Let's increase it a little bit. So this is the this detail column provides more in-depth information about the captured event. Although this solution isn't as helpful as monitoring system calls on other platforms, it is still useful in Windows when you just want to determine the network protocols a particular application is using. You can't capture data using this technique, but once you determine the protocols in use, you can add that information to your analysis through more active network traffic capture. And now advantages and disadvantages of passive capture. So the greatest advantage of using passive capture is that it doesn't disrupt the client and server applications communication. So it will not change the destination or source address of traffic, and it doesn't require any modifications or reconfiguration of the applications. Passive capture might also be the only technique you can use when you don't have direct control over the client or the server. You can usually find a way to listen to the network traffic and capture it with a limited amount of effort. After you have collected your data, you can determine which active capture techniques to use and the best way to attack the protocol you want to analyze. One major disadvantage of passive network traffic capture is that capture techniques like packet sniffing run at such a low level that it can difficult to interpret what an application received. Tools such Wireshark certainly help, but if you are analyzing a custom protocol, it might not be possible to easily take apart the protocol without interacting with it directly. Passive capture also doesn't always make it easy to modify the traffic an application produces. So modifying traffic isn't always necessary, but it's useful when you encounter encrypted protocols and want to disable compression or need to change the traffic for exploitation. When analyzing traffic and injecting new packages doesn't yield results, switch tactics and try using active capture techniques. And we have active network capture as well. So actually, I want to illustrate this here. Let's change it to draw here. Here. So now we will firstly client application here, and actually yes, target, and we need proxy man in the middle, man in the middle, proxy so this is the attacker's proxy here, and it's here, and we have actually we have another proxy here. Actually not, we just need server applications, server application, for example this is the server, and let's capture this. So here and here So active capture differs from passive in that you will try to influence the flow of the traffic, usually by using a man in the middle attack on the network communication. As shown in this figure, the device capturing traffic usually sits between the client and server application, acting as a bridge here. So this approach has several advantages, including the ability to modify traffic and disable features like encryption, compression, which can make it easier to analyze and exploit a network protocol. Actually not advantages, disadvantages of this approach is that it's usually more difficult because you need to reroute the application's traffic through your active capture system. Active capture can also have unintended, undesirable effects. For example, if you change the network address of the server or client to the proxy, this can cause confusion, resulting in the application sending traffic to the wrong place. Despite these uses, active capture is probably the most valuable technique for analyzing and exploiting application network protocols. We have network proxies here as well. So what network proxies does is we will learn in next lecture.